Raymond Kui, 20. Raymond Kui, 20. Raymond Kui, 20. Aladdin R. Ghana, 15. Aladdin R. Ghana, 15. Aladdin R. Ghana, 15. Noor R. Muhammad Birbidikov, 17. Noor R. Muhammad Birbidikov, 17. Noor R. Muhammad Birbidikov, 17. Muhammad Syed Dema, 34. Muhammad Syed Dema, 34. Muhammad Syed Dema, 34. Masudu Zaman, 5. Masudu Zaman, 5. Masudu Zaman, 5. Ibrahim Rob Job, 29.
Huh?
Oh, yeah, you're here. Okay. Mohammed Temakir, 30.
I'm here, Lashi.
Okay. Mikhail M. Safa, 5.
Yes, Lashi, I'm here.
Okay. Solomon Carlton, 6.
Yeah, number 6.
Okay. Sador Dadajonov, 8. Sador. Okay. Tamar Marik Daminov, 10. Tamar
I'm
Marik.
here. I'm here.
Okay. Christ David Georg Ob.
Yo. Yeah, I'm here.
Oh, okay. Hasibu Rahman Noor, 14. Hasibu Roman Noor, 14. Hasibu Roman Noor, 14. Mehrab Hossein, 15. Mehrab Hossein, 15. Mehrab Hossein, 15. Janitor Fedas, 21. Janitor Fedas, 21. Janitor Fedas, 21. Abraham K. Kromas, 22. Abraham K. Kromas, 22. Abraham K. Kromas, 22. B. Sir Phillips G. Russell, 25. B. Sir Phillips G. Russell, 25. B. Sir Phillips G. Russell, 25. Solomon K. Sawyer, 26.
Yes, Lashi, I'm here.
Oh, okay. Beham Tilahan Mamo, 29.
Yes, Lashi, I'm here.
Okay.
Yes, Lashi, I'm here.
Okay. Okay. Next, Laikun Asifa, 30. Next, Laikun Asifa, 30. Next, Laikun Asifa, 30. Valery Butuk, 31. Valery Butuk, 31. Valery Butuk, 31. Anna Akulova, 32. Anna Akula 32. Anna Akula 32. Lawan Tobacco Grapevine
I'm here,
33.
Master. I'm here.
Okay. Big Noor Ikram 34. Big Noor Ikram 34. Big Noor Ikram 34. Azamat Kalimulin 36. Azamat Kalimulin 36. Azamat Kalimulin 36. Okay. Sorry. They use the is language. Let me share my screen. Oh, I see. I'm not close. So your phone has something wrong. Okay, I see. I see you. Okay. If your microphone have something wrong, you can tell me through this Tencent meeting, or you can directly tell me through the WeChat. Both are okay. Yeah, sometimes the microphone maybe something wrong. Yeah, it's okay. Yeah, wait, so let me share my screen. Okay, can you see the slides? Hello?
Yes,
Anybody?
lecture.
Okay.
Yes.
Okay, so thank you. So let's firstly have a brief review about our last lecture. So last lecture, okay, we meaning sorry. Wait a second, wait a second. Something wrong. Sorry, wait a second. That's right. Why is there something? Okay, so in our last lecture, okay, we meaning discussed the host target development mode. Okay. Because that in this course, okay, when we mention the embedded system, okay, we meaning refers to the ARM, okay, because that ARM is the most popular embedded architecture among our daily life. So in this host target development mode, okay, why we need such a mode? It is because that the embedded system itself does not have the resource to compile the embedded application it needed by itself. So where we can develop an embedded application, okay, we can develop it in a conventional computer, okay, like here. So for an ARM-based embedded system, Okay, when we use such host target development mode. Okay, so the target is the ARM Linux, okay, embedded Linux, while the host system, okay, is a conventional operating system, okay, Ubuntu. So for the ARM embedded Linux, okay, we can use one such host target development toolkit called the ARM Linux GCC kit. So this kit toolkit has the entire compile toolkits, okay, including the compiler, linker, debugger, assembler, and so on. Okay. So we actually develop an application in the conventional computer, okay, and in a conventional operating system like Ubuntu. Okay. But we use a cross-platform compiler, okay, like the ARM Linux GCC, to compile it, so that okay, the executable generated from our source code here cannot be run, okay, under the Ubuntu OS. It can only be run, okay, on the embedded Linux system. Yeah. So why we say is the host target development mode? Okay, it is because that the application, okay, the embedded application is developed on the host machine, okay, but it is running on the target machine. Of course, the cross platform development introduce many difficulties. Firstly, okay, the debugging, okay, because that unlike our conventional programming, we can directly debug it in the development environment. Okay, because in our conventional application development, okay, the development environment and the running environment are the same. While here, for an embedded application, okay, its development environment and running environment are different. So how to debug it is a problem. Okay. But with the host and the target machine, okay, can connect it. Okay, we mentioned in our last lecture. Okay, it can go through the ports, or go through USB, or go through the Ethernet. Okay, of course, this is just the three main methods that can connect the host machine and the target machine. Of course, there are other ways to connect them together. So after connect them together, okay, so it is possible that okay, if the embedded machine has the ability to support, okay, we can do the remote debugging, okay, to show the debugging information on our conventional computer. Okay, it is because that sometimes, okay, the target machine is just an development board, okay, just an electrical board and with some chips, bars, and on it. Yeah, it actually this target machine actually does not have any output device like a screen or other things. Okay, so actually even the running result of the application should be displayed on our conventional computer. Okay. So we should connect them together, okay, for debugging or even for running. So generally speaking, the host target development okay, is because that we have to develop the application in the host machine, okay. But the running environment is still the embedded machine. Okay. Then here, this figure demonstrates the software, okay, especially the software development for the embedded system. Okay. So still, okay, it is on the left-hand side. Okay, you can see that these steps actually is the same. Okay, from the design to the linker. Okay, this part, this several steps and actually are the same as our conventional development of an of a computer application or a computer object project. Okay, that's the same. Okay, we create a project in the IDE and compile it. Okay, from compiler to the assembler to the debugger and to the linker. Okay, create an executable. But here to run because we develop an embedded software. Okay, so that we have to use different ways to do the debugging, or we need to move this software to the target machine, okay, like the target board and something. So here, okay, during this compilation, okay, one important step is the generation of the object file. So who generate the object file? Okay? It is the assembler. Okay? So the compiler will transform, okay, the source code to the assembly code, while the assembler will transform the assembly code to the object files, okay, like that. Then, okay, this object file, okay, this bytecode is very similar to the executables, but only after it is linked with needed libraries, then it is the executable that can be run. Okay. Otherwise, okay, without linking with the libraries, okay, this if you suppose you introduce some functions, use some functions within a certain libraries, then other functions cannot be run without linking to a library. Of course, if you really develop a piece of code that doesn't need any functions from any libraries, then that's okay. Okay, the linker will do nothing. Then this object file can be executable. Okay. So within the object file, okay, generally speaking, it can be categorized by the text and the data. The so-called text segment, okay, is the code, or we see the instruction. So they are read-only. Well, data, okay, data including the global variables and the static variables. Depending on whether they are initialized, okay, it is put in a different segment. So the data are stored in the high address, while the instructions are stored in the low address. Okay, so generally speaking, the cross compilation, okay, is complex and difficult. Okay, and nowadays there are two typical implementation of cross compilation. Okay, the first one is Java mode. It is because that you can develop a Java program. Okay, then you install an JVM, okay, Java virtual machine on the target machine. Then the Java bytecode can be run in the Java machine. Okay, so generally speaking, here the cross-platform, okay, is implemented by the JVM actually. So you don't care, for a Java developer, okay, you simply can develop any Java program, okay. Then it is the task for the JVM to do the cross-platform things. While another implementation, okay, typical implementation is the GNU GCC mode, okay. It has the cross-platform compiler, okay, for the different embedded architectures. Okay, so the ARM Linux GCC is an example, and here is the ARM Linux GCC is the cross compilation toolkits we will discuss in details today. So the GCC cross compiler, it consists of three components. The first one is GNU bin utils. Okay, it mainly have two compilation tools, including the linker and the assembler. So the bin utils, okay, this component, it provides the linker and assembler for the entire GNU compiler system. Then the second component is the GNU GCC. Okay. So it provides the C compiler for the GNU system. Of course, it also supports more languages, okay, than the C or C++. Now it can support the Fortran, Java, Objective-C, Ada, and so on. The third one, okay, is the GNU glibc. So this one it defines the system calls, okay, and other basic function calls. The system call, okay, this one is very important for the kernel programming. Okay, so other basic function calls, okay, refers to the function calls in the C or C++ libraries. So these basic function calls for the C or C++ libraries, I think you are familiar with. But for system calls, okay, why it is important? Remember in our previous classes, okay, we mentioned about the embedded software development. So we use an example that, okay, on the development board, okay, we try to light up some LEDs on the board. Okay, how to do that? We actually extend the device driver, for the IDEs. So we actually write some code, okay, to use the device drivers of the IDE by setting the bits of the register so that we can control the LEDs. Of course, we mentioned that there is a non-OS model development and also the OS model development. But in either way, okay, we need to extend the device driver of the IDEs. But you know, right? And since you have learned the operating system calls, so you know that the device driver, it can be viewed as a part of the operating system kernel, right? So for such kernel programming, okay, we have to use the system calls. So this example of the ARM Linux GCC version 4.3.2, okay, you can see that there are many tools, okay, ARM Linux tools within it. So here, let's discuss them in details. Firstly, okay, the GNU bin utils toolkits. The address to line. Firstly, I have to say, okay, you see the address to line, right? Then you say, okay, ARM Linux address to line, okay, ARM Linux, okay, AR. Okay. So actually, these things are all the executables. Okay, these things are all executables. So you can use them in the command line model. Okay, this is not a function. They are the commands, okay, executables, not a system function. So here, the address to line. So you know that the number 2, okay, usually refers to, okay, as the shorter of TO, okay, in English, okay, especially in the computer science environment. The address to line. So by its means, okay, this command is to translate the program addresses into file names and line numbers. Okay, so you may be wondering, well, why we need that? Okay, so actually, this one is mainly used for debugging. Okay, when debugging. So you know that if you compile, okay, you compile source code, okay, of course, you finally will generate an executable. But okay, you should know that for the executable, there exists a segment that stores the debugging information. Okay, unless you specifically set the compiler, okay, so that it will not generate that segment. It is by default, okay, your executable, okay, will have the related debugging information. And for what? Okay, so here, okay, address to line, okay, it actually given the program address, it output the corresponding source file names and the line numbers. Okay, so it actually used to debug. Okay, for instance, if we run a program, okay, and okay, it may be okay, it is report some error, okay, at a certain address. Okay, so maybe we can use this address to say, okay, exactly where it happens. So here, okay, given an address and an executable, it will use the stored debugging information in the executable to figure out the source file name and the line numbers, okay, which are associated with the given address. Yeah, so this is the meaning for the debugging. The AR. This AR, okay, AR stands for archive. So what are archive? Okay, here. So you know the library, right? Okay, you know the library. So actually, library is a kind of the archive file. Okay. So also, okay, here AR, this command can be used to generate a library. Okay. In more details, generate static libraries. Okay. So here, the AR commands, it can create, modify, or extract from archive files. So by definition, okay, an archive is a single file holding a collection of other files in a structure that make it possible to retrieve the original individual files. Okay, so such individual files are called the members of the archive. Okay. But for us, okay, the most familiar archive file, okay, is libraries. Okay. So the libraries essentially, okay, consists of many object files. Okay, actually, they are also constructed from object files. Essentially, okay, it provides the functions to our users. So here, okay, that means that we can retrieve the needed executables from the libraries. AS is short for the assembler. So assembler, okay, we already discussed. So its functionality need to assemble the assembly files to generate the object files. Okay, these object files, okay, will be then used by the linker, okay, to link with the libraries to generate the final executables. And C++ filter. This one decodes low-level names into username names so that the linker can keep the overloaded function from crashing. So here, this one is used in the C++ for the function overloading. So do you know function overloading? Anybody knows? Function overloading. Anybody answer me? What is function overloading? So you have learned Java, right? Java has something called a method overloading. So that can you tell me what is method overloading or the function overloading?
Having the same methods at the same class.
Yeah, have the same name then.
The same name for
Yeah.
two different functions or methods.
Yeah, you are right. Correct. So actually, this one is function overloading. Okay. Is a very common. Yeah, we can say that it is very common in the object-oriented programming language, right? You know what is object-oriented, right? So C++ is also object-oriented programming language, but C is not. C is not object-oriented. So for such object-oriented languages, so that it has such overloading, either function overloading or we say the method overloading. Anyway, you know that meaning, right? So the function name can be the same, but yeah, actually, when we implement it, actually, so we have the same function name, but with different parameters and different function body. So after this is called the function overloading. So here the C++ filter, is to handle these overloading functions. Then the G proof. So this one, read the given object file and establish the relationship between the symbol table and the call graph. Firstly, what is a symbol table and what is a call graph? So what is a symbol table? What is a symbol, right? A symbol contains word. Of course, firstly, variables. In more details, the global variables and the static variables. Then, as I mentioned in the last lecture, is a function. It also can be considered as a special type of variable, as a function type of variable. So the function is also included in the symbol table. So then the call graph. We know that in our program, usually we invoke functions, right? We invoke these functions. Or maybe here in the main functions, we may call the function A. Within the function A, maybe it calls the function B. The function B may call a function C. So such function calls, we use such call relationship is the age within the so-called call graph. So during the execution, the call graph can be created. Hello? Hello? Who are you?
I'm sorry for late. Can you count my attendance? Hello?
Oh, sorry. They are, yeah, so, okay, so you are Masudu Zaman, right?
Yes, Mr. Chairman.
Shit. Wait a second, sorry. Okay, wait a second, let me pick up my microphone, okay? Hello, can you?
Yes, 老师。
Okay, anyway, so 马术渣男 ，OK, I see you, OK. You are late, OK. Okay, let's continue, OK. NM, OK. NM, this one list are the symbols from the object files. Oh, can you hear me now? Hello? Anyone? Okay, you can.
Yes,
Yes, 老师. Yeah.
So the symbols, okay, I have just explained, okay, the variables and functions, okay. Then the object copy. So the object copy here is simply copy the content of an object file, okay, to another. So actually copy the bytecode, okay, within the object file, okay, to another. Object dump. This one is used to display, okay, information for one or more object file. So it have some it can, so it is used to use with different parameters. Okay, so you can display the particular information. In general speaking, okay, if it is still used for the debugging process, okay, when after you compile something, okay. So this one is also a very old, very old command. Okay, so it is firstly used in the Unix system. Okay. Very old command. Okay. Not only belongs to the ARM Linux GCC system. Then LD. Okay. LD. This one is the linker. Okay. The linker is usage is to combine a number of object files and archive files. Here, archive files meaning refers to the libraries. Okay. So during the combination, okay, as we explained in the last lecture, okay, we need to relocate their data and also their instructions. So that the symbols, okay, the variables and the functions, okay, we need to adjust, okay, their addresses. The run lib, this one is to generate an index to the content of an archive and store it in the archive. Okay, so just speaking, this run lib command is usually used after the AR. The AR is what? Okay, AR is archive, stands for archive. Okay, used to create an archive file. So AR, okay, it can create or modify libraries, okay, or retrieve some libraries. Okay. So if you use AR to create a new libraries, then after that, okay, you need to use run lib to create an index of the library. So what is the index? Okay, so it's like the index of a dictionary, right? Okay. So it means that if a program want to use the functions within your libraries, okay, it actually the function, okay, the function names, okay, is actually used to refer to the corresponding address, okay. In other words, the corresponding function entry, okay, in the libraries. So such reference, okay, is the so-called index created by run lib. Okay. Now, of course, if you use AR to modify the libraries, either you remove one function or you add one function, or you add some file or module, okay, then you need to use the runlib command to update the index so that the program can continue to use this updated libraries. Otherwise, if you do not forget to use the runlib, okay, the program it will call a function, okay, but the compiler cannot use this function to reference, okay, or we say to locate the correct function entry, okay, in the libraries. So actually, okay, it cannot get the bytecode of this function. So actually, the linking there, the so-called linking, is that it actually copies the function's bytecode, okay, to the object files. Okay? It essentially is the linker. This linker's work. Okay, if we cannot find the bytecode of the function, okay, you can see that your executable cannot be used. Then I read F. Okay, so here the ELF. Okay, the ELF stands for the executable and linkable format. Okay, so this is a common standard file format. Okay, for executable files. Also for object files and libraries. Okay. So this one is just to display the information, okay, for such ELF files. Okay. The size, this one lists the section size and the total size for each of the object or archive files. So by default, okay, the output of the size command, okay, is one line for one target file, okay, one object file or one archive file. Okay. So in general speaking, it lists okay, the structure of the target file. So you know that okay. So you know the processor, okay. Process, okay. Process have many sections, right? Okay. Actually, also a PE file, okay. A PE file have several sections, okay. So for that, okay, you can use the size, okay, to see the for each section is size, okay. The strip. Strip, this command is to discard the symbols from object files. Okay, for minimize their file size. So actually, this one, okay, the symbol information, okay, from object files, okay, this one actually is not useful when this object file, okay, to be executed. Okay, this one, this symbol information are mainly used for debugging. So actually, the strip discards this debugging information. Why? Why we need to do that? Okay, because that actually, this one, of course, it can save some space, right? But not so much. Because that it is used for okay, for embedded application, right? Because that usually we have very limited hardware storage on an embedded system. Okay, let's see. So the string, this one is not the type string, okay? This is a command. So this one can print the printable character sequence that are at least 4 characters long, or you can give the number of the length of the string. Okay, use as the parameter. And then followed by an unprintable character. Okay. Here, unprintable character, okay, usually stands for the end of the string. Okay, so you know that in C or Java, right? Okay, actually the especially in C, okay, the a string, okay, actually is actually an array of the type character, while okay, the last element of the character array, okay, is actually an unprintable character, so which is used to indicate, okay, this is the end of the string. So by default, the strings, this command only prints the strings from the initialized and loaded section of the object files. Okay. For other types of files, okay, it prints strings from the whole file, file. So actually, so what are use of the strings? Okay. So here, for instance, you get an executable, okay, or some object files. For instance, this is an, let's say, a small software, okay, that is a register machine, okay, that requires to type in, okay, some username and password, okay. So this is a very common small software, right? Okay. Or you need to type in the username and the registration number, okay, like something like that. Okay. If you type in some wrong password, wrong registration number, okay, normally, okay, that software, okay, or that application will pop up a window with some error message, right? Okay. So here, if we want to crack such software, okay. So, but here, of course, this software, we just have the executables, okay. So we know that if we use some analyzer, okay, like the ODDBG or ADA, okay, these things we can reverse the bytecode to the to assembly code, okay, but we cannot reverse the bytecode directly to the source file. Okay, normally it is impossible. We can just see the assembly code of this application. Okay, then why we need the such strings? Okay, then because that we see, okay, we see the error messages, right? Okay, then we know that it should be around the place that we type in, okay, the input, the password or the number, okay, and it must have some if or other branch statement, okay, to say that, okay, whether this input is correct or not. Then it will output the error messages. Then here, once we get the strings, okay, we can manage to do locate the place, okay, where the string is, and when we look around of the output string, okay, we may see the branch statement or the if statement. Okay. For some very simple application, okay, maybe we can directly see the password around it, or we see the address of the password, okay, or the number. Okay. So this is anyway. So this such strings is the very beginning for give us some guidance to crack or obviously to analyze some executables. Okay, then let's move on to GNU GCC toolkits. So for GNU GCC toolkit, this is relatively simple. Okay, it's meaning about the compilers, okay, or some components of the compilers. Okay. For example, CPP. Okay, this one is not this. This is not the C++. Okay, this is the C preprocessor. Okay, the P for the preprocessor. While the G++. Okay, this one is the C++ compiler. GCC. Okay, is the C compiler. GCC bug. Okay, this one is the shell script to create bug reports. Then the lib GCC star. Okay, this one is the runtime libraries for GCC system. Then the lib std C++. Okay, you know std, right? Okay, stdc. Okay, so this is the standard C++ library. So includes the most used functions in the C++ programming language. While the lib soup C++. Okay, so this is to provide library functions supporting C++. Okay, let's move on to the third components. Okay, GNU glibc. Okay. So for glibc, okay, they also includes many commands. Okay, but here we will go through them quickly. Okay, because that actually for them in most of times, okay, we do not need to use them. Okay, actually some commands are within the GNU bin utils. Yeah, sometimes we will need it. But for the commands here, generally speaking, you will not need to use them, okay, in most of the time. So here we go through them quickly. So, okay, cache segue. So this one is used to debug the segment faults in program. Okay, then it output is the content of registers and plus base trace. Okay, so I think that do you know what is the segment fault? Okay. Or have you met any segment fault during your programming? No, you have not met any segment fault when you write a program. No one have met any segment fault.
Segment?
Yeah, segment fault.
No, I guess.
No, I think you are in the, you are in on the ground train, right? The segment fault, okay, the most the majority reason that can cause a segment fault, okay, is the stack overflow. Okay. I think that if you, I think that, yeah, because that you meaning okay, use the Java for programming, if you program in C, okay, it's very possible that you cause a segment fault because that in C there is no array index checking, okay? So cause some to cause some overflow problem is very possible. Then the backtrace, okay. So here backtrace is generated from the call graph, okay. So it means that where the segment fault happens at which command, okay. Then this command must reside in a certain function, okay. So then this function is called by whom, okay. So this is the caller is and the caller's caller, okay. So this one will construct the backtrace of the segment fault. Okay. Then GenCat, so this one generates the message catalog. And getConf, this one get the current configuration variables for current system and their values. So this one is the meaning refers to the environment variables. Okay. Then getEnt, okay. This one is get the entries from the specified administrative database using the specific search key. Then glibc bug. Okay, so this one is to create the bug report for the glibc. Then icon. This one use the gcon modules to convert to and from character sets. Okay, so and here the icon config. Okay, so this one read the icon module configuration files and write fast loading icon modules configuration cache file. And the LD config. Okay, this one config dynamic linker. Okay, runtime boundings. While LDD, this one print the shared objects and libraries required by each program and command line. The LDD libc4, this one is to assist LDD with object files. Then the locale, is to define the cultural conventions of a language and the region. Okay? So like something like the time zone, okay? Like the time zone in your system setting, locale. NICD, this one is the daemon. You know daemon, right? Actually, in the operating system, there are many daemon processes. Okay? The so-called daemon is a program or process that runs continuously. Okay, that provide certain services, or watching something and so as to reflect to certain events. So here, this NICD is a daemon that provides a cache for the most common name service request. Okay, so this one is related to the here the following command here, the NICD NICI check. So this command is to check whether or not a secure model is necessary for NIS lookup. So NIS is what? Okay, in more details, okay, NIS plus is what? NIS it stands for Network Information Service, NIS, okay, the first letter of these three words. The NIS plus, okay, NIS plus, okay, is similar to the original NIS, but with more features. The NIS plus name service, okay, is designed to conform to the shape of the organization, okay, that or something, or maybe like a company, or school department, or government department, okay, who installs it, and wrapping itself around the corners of almost any network configurations. So the namespace of the NIS plus is dynamic because updates can occur and be put into effect at any time by any authorized user. So NIS plus, this one enables you to store information about workstation addresses, security information, mail information, Ethernet interface, and also network services in central locations where all workstations on a network can have access to it. So this configuration of network information is referred to as the NIS namespace. So the NIS namespace, okay, generally speaking, it is hierarchical. It a hierarchy architecture. Okay, and you can imagine that it's like the file system, okay, a directory file system in the Linux or we say the Unix system. So such a hierarchy structure, okay, of the NIS namespace, okay, makes it makes the NIS namespace can be configured, okay, to conform the logical hierarchy of an organization, and also the namespace layout of the information, okay, is unrelated to its physical arrangement. So the NIS NIS plus namespace can be divided into multiple domains that can be administered automatically. So here, if the organization use the NIS namespace for their internal network, so the clients who want to use such a network may have access to information in other domains in addition to their own, but only when they have the appropriate permissions. So here the NISCD NIS check is used in the NIS pass service. It looks up and resolves an NIS name, NIS pass name, and returns a copy of that object from a NIS pass server. Okay, then let's see the steps of compilation. Generally speaking, yeah. Firstly, I want to know, have you taken the compiler principle course? Compiler principle. Have you taken this course in your previous semesters? Compiler principle. No, yes or no? Can anybody answer me? Compiler principle. Have you taken this course before? Hello, can you hear me?
Oh,
yeah.
yes, Lao Shen, yes, I think so. Like,
Yeah, so compiler principle. So you know that
Yes,
I think
Laoshi.
that you should know something about the entire compilation process, right? Okay. But the first step of the compilation, is do the pre-processing. And so that you need to do pre-process the source code before really compiling. Then the second step is to compile the pre-processing result into the assembly or object file. If it if the compiler can compile the pre-processing result into assembly code, then it's time for the assembling. To assemble the assembly code to the object file. Then finally, it's a linker. It's a linker's job to link multiple object files together to generate one object file. Always say the one executable. So this is general steps of the compilation. But here, let's see more details about the compilation using the ARM Linux, the ARM Linux GCC. So in the pre-processing, so how does the compiler know what the type is? Because usually we will use some self-defined types, right? So for a better programming style, we usually define such self-defined types in a header file, right? Or we do, of course, if the program is very small, you can simply define in your C source file. But if the project is relatively big, it is better to define such functions and the types in some header files. So here, suppose in the game.c, this source file, we use a self-defined type, test_t. Then this one, okay, is defined in the header file, okay, deck.h. Okay. So here, to know, okay, what the type desk.t is, okay, it actually the preprocessor, okay, will copies the deck.h to the game.c. Then how can the preprocessor, okay, know that it should to find the definition, okay, of the deck_t, okay, from the deck.h, okay? Either because that in our source code, okay, we use a pound, okay, include, okay, deck.h, right? Okay. So here, the preprocessor will process such instructions that prefixed with pound, okay, with pound sign. Okay. So it reads the pound sign, okay, and will do the pre-processing. Okay. So for this, okay, so here for GCC, okay, we know that the GCC is the compiler, okay, of the C, right? C language. Okay. So if you provide GCC, okay, with different parameters, you can determine, okay, so which compilation steps it will be executed to. So here, suppose we supply the GCC with a -e, okay, then it will just do the pre-processing. So here, if we execute this command, okay, GCC plus GCC -e -o, okay, game on .txt and game.c. So here it actually generates a pre-processed file of the game.c. So the preprocessor, okay, meaning do the following things. So it will copy the files, okay, that is included, okay, by the compound sign and by the pound sign included instructions. Okay. Also, okay, we sometimes, okay, we use the pound sign define. Okay. So you know that the define pound sign define, okay, this one is used to implement the macro, right? The macro in C. Okay. So essentially, okay, this macro, okay, for instance, we say define a big uppercase N and 10, okay. So essentially, this means that we use the uppercase N to represent the integer value 10. Okay. So here, the preprocessor will also need to handle the define instructions. Okay. Actually, it substitute the text, okay, in the pound sign define instructions with the actual values. So that it replace, okay, each macro that where it is used. So for instance, if you use the define uppercase N10, okay, then you use some place like the for, okay, I equal to I equal to 0, okay, then I less than what I less than N and I plus, okay, so this is the beginning of a loop, right? Okay, so loop from 0 to n minus 1, okay. So in this place, okay, after pre-processing, then this one will be replaced by the n, the n will directly replaced by 10. So here it comes the I less than 10 minus 1. Oh, sorry, I less than 10, you know. That means that I will loop from the n to 9. Also, okay, there are some conditional compilation sign, like the compound sign if and the compound sign else. This one, okay, I think that you may not use it, okay, because that this one is widely used, okay, in some big project, okay, that has that, for instance, the Linux kernel, okay. We know that for Linux kernel, okay, you can determine, okay, which module to be compiled, while which module just say that we do not use it. Okay. So how to determine which module or which source file to be compiled or not. Okay. So in the Linux kernel source code, such things are implemented by this. Command sign if and command sign else. So it will check the configuration during the compilation. Of course, some of the compilation to compile Linux kernel, you can use the command line module, or you can use some graphic user interface module. But essentially it's the same. It supply some parameters which will be checked by the if here to determine the particular sections of source code to be compiled or not. Then the second step, compiling. So here we set the compiler translate your source code. Actually the source code here the source code is already being pre-processed into assembly code. So the compiler will figure out what you want to do by analyzing your code. So here, if you have some syntax error in your program in your source code, the compiler can report such error. Of course, the compilation will terminate. Sometimes we see compiling. We refer it as the entire compilation process. But here we just say this is the one intermediate step during the entire compilation process. Then assembler. So here assembler, we say AS, the AS command, it can convert the assembly code into object code. So although object code cannot run, but it is nearly, it is almost the executable, because that it just need the related libraries by the code. So we can use GCC -C, this option to generate the object code of the source code. For instance, here, if we use the GCC -C game.c, this one will produce game.o, such object file. Suppose there's no error happens during the previous compilation steps. But finally, the linking. So the linker will accept the object files created by assembler and convert them to executable. So if we want to use the link LD command directly, then this is the format like that. If we want to link the main.o and game.o together, we can use the command like that. So the games, the game.o and the main.o, these are two object files. Therefore, all functions in the object files are put together. Also, their data are put together. Generally speaking, we rarely use LD commands alone to link object files. Generally speaking, because linking is the final step during the entire compilation process. So generally speaking, we will use commands like GCC to execute the entire compilation process, which is including the linking. The linking will be automatically done if there's no error happens during the compilation process. Okay. So this is the ARM Linux tools, okay, corresponding to the compilation process I just mentioned. Of course, the ARM Linux GCC, okay, and this one has a similar functionality and usage as the GCC, okay. It can be it can compile, okay, it can finish the entire compilation process, or okay, we can supply different options to it so that we can let it execute to a certain step during the compilation process. While the assembler, okay, is the ARM Linux AS. While the linker, okay, is the ARM Linux LD. Then the library manager here is the ARM, okay, Linux L. So if for a conventional okay GCC system, okay, so here is no ARM Linux prefix. They will be the GCC S, LD, and L. But for the ARM Linux GCC system, okay, it has this prefix. Okay. Okay, so let's take a look at this figure. Okay. So this figure demonstrates the compilation, okay, within with the ARM Linux GCC system. So firstly, okay, we know that to compile a C project, we need the C source code and also the header files. Okay, they both with them, okay, and they are fed into the ARM Linux GCC compiler. Okay, then okay, the first step, okay, is the pre-processor. Okay, it will handle the include, the define, or it will rely on the compiler parameters. Okay, with the pound if, pound sign if, and the pound sign else. Okay, to say okay which part of source code should be compiled. Okay, then it will do the pre-processing. Copy the header files, related header files, okay, to the C source code, and also replace the macros using a source code with the actual value. Then then the second step is assembling. Then assembly, okay, that assembly code, okay, will be fed into the ARM Linux AS, okay. This one will generate the object file. Also, the source list. Okay. This one source list is also being used as some reference information or debugging information. Object files, okay. So then it will depend on, okay, you want to generate an executable, or you want to create a library. Okay. So it depends on the goal of the project. So suppose you want to generate an executable, okay, then okay. The linker here will link the used libraries. Okay. In more detail, okay, it copies the bytecode of the library within libraries and merge them with the object files. Okay, of course, the linker will adjust the variables, functions, address, and also the instructions. Merge them and adjust the addresses. Okay, so the linker, okay, will also generate the here the reloc stands for the relocation, okay, because that during the merging, okay, the original the variables and the functions are not with the original addresses. Okay, so here it includes the relocation problem. Also, okay, it will generate the symbol tables that includes the global variables, static variables, and also the functions. Now, finally, okay, in the linker will output an executable. Well, here for this branch, okay, for this branch, it means that we want to build a library. Okay. To build a library, okay, we will use the ARM Linux Air, okay, archive, okay, to create the library. Okay. It will output the library list, okay, as the AS, okay, and also, okay, it will create the libraries from the object files. It will also, okay, to adjust the or adjust the different adjust the addresses. But here within the libraries, okay, it will the more important things is that it need to provide the index, okay, to the outsider, so that the outsider program can use the functions within the libraries. Okay, then this step, okay, this step is done by the runlib. Okay, runlib can create the index for libraries, so that the compiler can locate the functions within the library. So this is the compilation process within the ARM Linux GCC system. Okay. So one branch is to generate an executable, another branch is to generate a library. Okay. So ARM Linux GCC, okay, it is the ARM embedded Linux version of GCC system. Okay. So it is a specialized version of GCC. Okay. So it supports multi-platform compilation. Okay. Especially, okay, because that it is used for the ARM, okay, system, so it has a very good efficiency. Generally speaking, okay, when comparing with a general C compiler, it has its efficiency higher than the normal is higher than the normal compiler for C, for 20 to 30%. So the usage of the command usage, okay, for the ARM Linux GCC, okay, here is similar to the GCC. Okay. Generally speaking, the common usage, okay, is to create an executable, okay, and also, okay, we can provide the parameters in the command, okay, to determine, okay, which compilation process, okay, pre-processing, compiling, assembling, and linking, okay, which is compilation steps to be executed to, okay, by determining the option. So here, if you are interested with the full usage of the ARM Linux GCC, okay, you can use the man. Here, man stands for the menu. Okay, man, and this man is a Linux command. Okay, not an ARM Linux GCC command. Okay. You can use man to check the usage of other Linux commands. So use man ARM Linux GCC, okay, you can see the menu of the ARM Linux GCC, the full usage of them. And it is very complex, but here we just see some simple usage of the ARM Linux GCC options. So here, minus big S, okay. So with this option, minus big S, the ARM Linux GCC compiler just do the compile, okay, without the assembling and linking, okay. So here, it will ARM Linux GCC, minus S min.c. It will generate an assembly file, okay, min.s, okay, So here, if you use some editor to check it, okay, you can see the corresponding assembly code of your source code. Of course, okay, it includes something from the header file, okay, and also the macro is replaced. Okay. Then minus uppercase E. This one is just do the pre-process, okay. Do not compile, assemble, or link. Okay, so in the Linux, okay, if you want to check the result of the such commands, okay, for instance here, okay, we can generate the pre-process result of the main, okay, min1.c. Okay. Then you can use something like gedit, okay, or vim or vi. Okay. This is frequently used editors in Linux system. While -c, okay. So this one, okay, is despite the linking, okay, all the previous combination steps are executed. Okay, so here it will generate the object file of the source code. While -o, okay, this one will generate a target file. So here it can generate an executable, okay, like that. Okay, so Linux GCC -o main and main.c. So here means that we generate the executable main from the source code main.c. But also we can generate something else. Okay, for instance, here we know that the -s, okay, is to generate an assembly code. Then here, okay, we can generate the main.asm. ASM is means the assembly file. Well, the minus include. This is the usage of such command is like we add one line of pound sign instructions within the source code. Okay, so it actually can include a certain file. Okay, so for instance here, suppose we execute the command, okay, Linux GCC main.c minus include type.h. So here it has the same effect that within the main.c, okay, we add one line at pound sign include type.h. Well, the minus uppercase I, okay, uppercase I. Okay. This one uppercase I dir, okay. So this one, okay, refers to where the compiler will search for header files. Okay. So if we use this minus uppercase I dir, okay, the compiler will search for header files in this specific directory. Okay. By default, okay, it will search under the current directory. Then it will search for the default directory of header files. Okay, so this default directory of header files, okay, refers to the header file directories of the GCC system. Okay, then the minus uppercase I, okay, it will can cancel the effect of the uppercase I dir. Then minus big L dir. Okay, so this one is similar to the uppercase I dir. Okay, so but this one is used to specify the path to search for libraries, and then the uppercase minus uppercase L, okay, is cancel the effect of the uppercase L dir. So this one is used to specify the path to search for your, especially for your own for your private libraries. Okay, if you just use the standard libraries, you do not need to use such option. Okay, time is up. See you next time. Bye bye.
Lauscher, ID 22. I came to the class a little bit late, so well, I was in the class.
Brahim.
Yeah.
Okay.
All right. Thanks, Lauscher.